So hi everyone, in the last video we have learned about the nomenclature of beta-lactam antibiotics such as penicillin, cephalosporin. Today we are going to see the degradation of beta-lactam antibiotics such as penicillin, cephalosporin. This topic is very important for the different competitive exam, pharma competitive exam. So many questions asked, and also most importantly it is important for semester exam. Okay, so I will tell some important points that these beta-lactam antibiotics such as penicillin and cephalosporin, they are unstable in the presence of four different conditions. What are they? Number one is in the presence of acid. Number two, in the presence of base. Number three, in the presence of water. And number four, in the presence of beta lactamase enzyme. Okay. This beta lactamase enzyme is produced by the bacteria so that they can save themselves from the beta lactam antibiotics. Okay. Next, water is also very important, and in the presence of acid and base, it is unstable. Why it is unstable? Because it shows Zwitter ionic effect. Shows Zwitter ionic effect. Number one thing. Number two, it is acidic also, it is basic. It shows acidic nature also, and it shows basic nature also. That's why it can accept proton also, and it can accept electron also. That's why in the presence of acid and in the presence of base, it shows it different chemical reaction, and ultimately it degrades. That is the breakdown of chemical structure, mainly the beta lactam ring. Breakdown of beta lactam ring takes place, and when this beta lactam ring breaks down, the activity, the antibiotic activity of the antibiotics will be lost. Why? Because this beta lactam ring is the most important and the crucial and essential part of the antibiotics, and it shows the pharmacological action, antibiotic action, because of the presence of the beta lactam ring only. Why? Because it goes and fixes with the cell wall of bacteria. Where it fixes? On the neck and NAM. There only. Four-member structure. So on the neck, N-acetyl glucosamine and N-acetyl muraric acid, which are very important. On that only, that beta lactam ring fixes and it shows its activity. Okay. Now we'll see the degradation of beta lactam antibiotics in the presence of base. First we'll see that one. Okay, degradation of beta lactam antibiotics such as penicillin in the presence of base. So let's draw the structure of penicillin. See, this one is the structure of penicillin, right? In that, this is the beta lactam ring. Here nitrogen is present, and along with that you will see one C double bond of OH acidic group is there, and along with that CH3 is present here, right? Now what will happen? This is the penicillin structure. So when OH is present, that is basic environment. When the OH is present, that is basic environment, what will happen? See, this C double bond O, that is carboxyl group, and this C double bond O, that is carboxyl group, they are very important in the structure. Why? When this C double bond, in this C double bond O, this oxygen is highly electronegative. Here also this oxygen is highly electronegative. So what will happen ultimately? Del negative charge will be present on the oxygen. Why? Because that oxygen is more electronegative. It will try to withdraw the electron towards itself. So more electron density will present on the high electronegative atom, and that carbon will be partially positive. Same here also. Now what will happen? When this is partially electronegative, this is partially electropositive. In the same way here also, this oxygen is partially electronegative and that carbon is partially electron positive. Okay. So this OH is also negatively charged, right? Which one? This one. This is partial negative. This carbon is present here. This is partially positive. Now this OH base is negatively charged, right? So it will go and it will bind with the positively charged carbon here. So when it will bind with the positively charged carbon, what will happen? Leave this part now. I'll add later. Let us see that beta lactam structure mainly. So in the beta lactam structure, what will happen? See, that carbon is earlier having 4 carbons, the 4 bonds, right? Now what will happen? When this OH will come and this OH will bind here to the positively charged carbon. Now this carbon is having 5 bonds. So carbon having 5 bond is unstable. Why? Because it is tetravalent. So when 5 bond is present, what will happen? It will try to break down 1 bond and it will be with 4 bonds again. So what will happen? This bond will break or this one will break? Obviously this one will break. Why? Because this is highly electronegative again compared to that carbon. Nitrogen is more electronegative because FONCl, FONCl, these 4 atoms are highly electronegative in the periodic table. So when it is electronegative, it will try to don't withdraw all the electrons present on this bond towards itself. This nitrogen will be again negatively charged. So when this nitrogen is negatively charged, what will happen? H plus will go and bind with the negatively charged nitrogen and it will form the structure like that. Double bond or single bond OH. Here N, H will be present. And along with that, remaining bonds are present like that. So here I forgot to mention this 5-member structure like that. Okay, this is most important. Now what will happen? See, this is the beta-lactam ring. Now it is as earlier. No, the beta-lactam ring is broken now. So when the beta-lactam ring is broken, on the neck and nail on the cell wall of the bacteria, that beta-lactam ring is 4-member structure. In the same way, this is also 4-member structure. So it will go and bind with fix in that. So ultimately, what will happen? That bacteria will feel like that cell wall is completed, but it is not completed. Ultimately, pores will be there, and when pores will be there, then fluid will be going inside, and ultimately the bacteria will die because of bursting or collapsing. So this beta-lactam ring is now broken down here. So when it is broken down, ultimately now it will go there and it can fix there. No, it can't go there and it can't fix. So ultimately, that beta-lactam antibiotics lost its antibiotic nature. Now I will tell you a very important point. What it is called? Penicillin. Earlier it was penicillin. Now it is called penicillinoic acid. Okay. Now one thing is that this will again undergo reaction. Let me draw the structure again. So that structure was like that, right? RC double bond O, single bond NH, and along with that, one carbon was there, double bond O, single bond OH, and another nitrogen is there. It is connected like that. Right? Now, what will happen? See, from here, if any single carbon is having 2 oxygen on that, it is unstable. So CO2 will remove from there. So once CO2 will remove, that is called decarboxylation. That is called penicillinic acid. But when decarboxylation will happen, that CO2 will remove and it will form the structure like that. R, C double bond O, single bond NH. Along with that, this carbon already having hydrogen earlier, one hydrogen is there. Now this hydrogen will go and bind with this carbon. Okay, so here another carbon that is called CH2 will form. Okay, and along with that, this carbon is there, right? So bond will break here and here. So when the bond will break here and there, it will form 2 things. Number 1 thing is called C. Again C. This bond is broken here, and in the environment OH is present. Why? Because basic environment. So this OH will go and bind here also, and it will go and bind here also. When a carbon is having 2 OH together and 1 hydrogen present from earlier, what will happen? These 2 OH again unstable because though both are same and because of the steric hindrance they will be unstable. Ultimately, what will happen? From one bond OH will grow, from other bond hydrogen will go, and they will lose H2O, water. That is called dehydration. And when dehydration will happen, the bond will form. What will finally form? That one you see like that. C double bond O, single bond H will be there. This single bond H, it went there, and from there one OH gone, then one bond is there. This bond will be connected with the oxygen. So C double bond O. That is called aldehyde. That is called aldehyde. Okay. So today it is called phenylaldehyde. Phenyloic aldehyde. Okay. What it is called? Phenyloic aldehyde. And the phenyloic structure of phenyloic aldehyde is like that. C double bond O, single bond H. That is called phenyloic aldehyde. Okay, so can you please tell me, penicillin will first convert into penicillinoic acid, and that will again convert into penyloic aldehyde. That penyloic aldehyde again degrade into, now I'll show you a very important part you have to remember. Okay, leave it aside. Now you see there. So first part is this one. Okay, first part is this one, right? This is penyloic aldehyde, right? And second part will be this one. This one. And that is first part. And that is second part. And that second part is called D. See, 1, 2, 3. How many members, how many structures are there? 1, 2, 3. And along with that, nitrogen is also present here. So that's why it is called D-penicillamine. D-penicillamine. So you have to remember that penicillin will convert into, first it will convert into penicillinic acid, and then it will convert into penicilloic acid. Then due to decarboxylation, that is CO2, it will convert into penylo aldehyde. Again, this one again broke down into two parts. One is called D-penicillamine, and another part is called, one is D-penicillamine, another part is called penylo aldehyde. So this is the simple degradation of penicillin in the presence of OH, that is in the presence of base. Okay, next we will see the degradation of penicillin in the presence of acid. That is also very easy. See, very easy means, first of all, what is that? Penicillin. What is that? Simply penicillin, right? And when this penicillin will be reacting in the presence of H plus, that is acid. Why? Because in presence of acidic medium, that is H plus. In presence of acidic medium, that is H plus. Now this is beta-lactam ring again. Now what will happen? This one is electronegative, so negative charge will be present. So when negative charge will be present here, how negative charge will be present now? Because it is highly electronegative, it will withdraw this electron from this bond. So now it will be oxygen withdraw electron from this bond, negatively charged. When it will be negatively charged, only single bond is present here, because the electron present on the other bond is now withdrawn. So only single bond is present here. And see what will happen at that time. The bond present between nitrogen and hydrogen will be donated by nitrogen to this. So ultimately the structure will be like that. R C double bond O. Earlier it was double bond O, but now it will be single bond O negative. Okay. Along with that, two bond is present and hydrogen is removed from the nitrogen. Now again see, this is negatively charged. Here you see this oxygen is also negatively charged. Why? Because it is highly electronegative. So partial negative charge is present here, and this is partially positively charged. So what will happen? This negatively charged negative ion from this oxygen will go and bind with the positively charged carbon and form a bond here. So the bond will be like that, carbon. Okay, not this one. After that, one carbon, huh? So it will form bond here, double bond is present here, and it will also form bond with this one. So when it will form bond with this one, earlier it is connected to nitrogen also, right? So now this carbon is having again 1, 2, 3, 4, 5 bonds. So when 5 bonds are present, one bond will be breakdown. So when one bond will be breakdown, this H plus, other H plus are also present because acidic medium. So another H plus will come, and this nitrogen is now negatively charged. Why? Because it is highly electronegative compared to this carbon, and when highly electronegative, it will withdraw all the electron present on the bond and this electron here. So this nitrogen is negatively charged. So this H plus will go and bind with the negatively charged nitrogen, and it will form NH. It will form NH. Now see, this was the beta-lactam ring. Now again the beta-lactam ring is broken or not. So here is that. Yes. This was the beta-lactam ring. Now since this bond is broken, so again beta-lactam ring is broken or not? Yes, beta-lactam ring is again broken. And when this beta-lactam ring is broken, again this penicillin will lose the structure. When it is that structure is broken, it will lose the antibiotic character. And when antibiotic character is lost, ultimately it will not affect and it will not show its pharmacological effect or not show its effect on the body. Which effect? Antibiotic effect. So again, in the same way, when in the presence of acid happened, in the same way here also it will happen. What will happen? This penicillin will convert into penicillinic acid, then penicillinic will convert into penyloic acid, and when penyloic acid will convert into penyloaldehyde and dipenicillamine. Okay, thank you. This is the degradation of penicillinic acid or degradation of penicillin in the presence of acid and base. In the presence of water also same thing will happen. H plus is also present, OH minus is also present. It can easily degrade. And the most important thing I want to tell you, why beta-lactamase enzyme is also breaking down. Because in the beta-lactamase enzyme, what is happening? Ultimately, bacteria will form an enzyme. That enzyme will go and bind with this one as a scissor. It will act like scissor. So it will act like scissor, and ultimately what will happen? It will break the bond present between the carbon and nitrogen. And when the bond is broken between carbon and nitrogen, again, ultimately beta-lactam structure is broken. And when beta-lactam structure is broken, it will not show its antibiotic activity. Ultimately, bacteria will be saved. That's why bacteria, and that condition, bacteria is called resistant. It is resistant to antibiotic because antibiotic is unable to kill the bacteria. Okay. Now, can you please tell me what are the antibiotics which kills the bacteria? That is called bactericidal antibiotics. So the example of bactericidal antibiotics are Bewafa. Bewafa. What is Be? It is beta-lactam antibiotics. That is penicillin and cephalosporin. And what is Ve? It is vancomycin. What is A? Aminoglycoside. And what is Fa? That is fluoroquinolone. Sorry, Ve means vancomycin and last A is aminoglycoside. F is fluoroquinolone. Okay? Thank you so much. You have to remember all these things.